Hello everyone and welcome to Unit 9. We're going to talk about logarithms this unit. The idea of logarithms and why they're so important is this idea of solving for an exponential function that we do not know how to solve for. And so logs were created to solve for exponential functions and to deal with solving equations that really have such large numbers, and how do we solve for that without having to write them all out. And so logs were created to solve this problem. So if we're going to look at the beginning of the logs unit, this is a long unit and one that you need to stay on top of, and one that we're going to look at right through May and right into the reviewing for Regents. So we'll start with this one. Have you ever had someone tell you you're speaking too loud or too softly? The volume on the television was turned up too high or down too low? While sensitivity to noise can vary from person to person, in general, people can hear sounds over an incredible range of loudness. Sound intensity is measured in physical units of watts per square centimeter, but the loudness is typically reported back in units called decibels. And so here is the table. And this is actually a really neat concept. That is the intensity of the sound. And the idea of the think about the situation is, are the intensity and decibel numbers in order of loudness that you would expect for the different familiar sources? And the answer should be yes, and I would expect you to pause this right now and figure out B, what patterns do you see relating to the sound intensity with the decibel? So pause it and see what you figure out. What pattern do you see? And so hopefully you saw that as the decibels increased by 10, the intensity, the exponent of the intensity, increased by 1. And so the question now is, can you create an equation that will tell you intensity to decibels or decibels to intensity? So what I want you to do right now, and that's what this bottom question is talking about, can you create it? And actually they give it to you. You should have seen that when the exponent is 0, the decibels are 120. And so therefore, that we have the starting value to be 120. And we know that as the exponent increases by 1, the actual value increases by 10 for the decibels. And so therefore we have, if it was 10 to the 0, we know that would equal 10 times 0 plus 120. And 10 to the first would equal 10 times 1 plus 120, which would give you 130. And so therefore we have an equation that can help us take the intensity and create it into being decibels. So the key to discovery of this conversion is the fact that all sound intensities were written in powers of 10. But where do logarithms come into play? Logarithms come into play when what happens when you have readings like 3.45 as your intensity or 0.0023 as your intensity. And that's where logarithms really come into play, that you're going to help solve this. So right now, we're going to leave the more difficult ones because I know some of you don't have calculators at home. We got to figure out how to express this in a power of 10. So 10 to what power will equal any of these numbers? So we're going to do the beginning ones. 10 to what power will equal 100? Well, that one should be a little obvious. It's 2. 10 squared equals 100. What about B? 10 to what power will equal 10,000? Well, that answer should be 4. And 10 to what power will equal 1,000,000? And if you use your calculator, you'll see that that is 6. You will realize here that the shortcut, and most of you probably saw that, is that the number of zeros is the exponent here. Will not always work like that, as in, let's go to D. In that, how do we get a decimal? 10 to what power will give you 0.01? Well, notice that the decimal place moved over 2 here. The decimal place at 1 moved over 4. The decimal place at 1 moved over 6. But in this case, the decimal place moved over how many spots? 2 in the left direction. And therefore, since it's in the left direction, we know that the answer is -2. The answer here is -2. Moved over 2 decimal spots. In this case, 10 to the 1, 2, 3. Okay, -3 there. 10 to the -3 equals, oops, nope. As you just heard me, that is not correct. 10 to the -3 does not equal, it does equal 0.01. It does not equal that negative. That negative is key. This cannot be done. And why? 10 raised to any negative exponent does not make any number negative. It makes it smaller. So please note, this cannot be done. 10 to the -3 equals 0.001, not -0.01. So we need to understand that 10 raised to any negative exponent does not make a number negative. We're going to leave F, G, H, and I in for class. So we'll scroll number 2 here. Again, we're going to leave some stuff to do in class, so bear with me here. Suppose that the sound intensity of a screaming baby was measured as 9.5 watts per meter squared. To calculate the equivalent of intensity in decibels, 9.5 must be written as 10 to what power? So I want you to pause the video. I need you to answer A and B. Okay, I need you to answer A and B, and you need to look at this and really try to understand what A and B is asking, not C and D. So hopefully you realize that 10 to the 0 is 1, 10 to the first is 10, and so that the exponent must be between 0 and 1. Then which two integers, values in part A, is closer to the required power of 10? Well, we better know that it's close to 1. It's not close to 0. 0 is closer to 1. We need to be 10 is closer to 9.5. Again, we're going to relook at C and D again when we have calculators in the classroom. So here's the real meat of the unit, or today's lesson. As you probably discovered, it's not easy to solve equations as 10 to the x equals 9.5 and 10 to the x equals 0.0023. And you can't even estimate it that well. So we've created logarithms. And the idea of logarithms is if 10 to the x equals y, then x is called the base 10 logarithm of y. And the definition, here's the definition. Log base 10 of a equals b, if and only if 10 to the b equals a. And so we can rewrite this, and you'll notice that b is the answer. So 10 to the b equals a, and that tells us that log base 10 of a equals b. You'll notice that the b is the exponent in the exponential function. These, and the b is alone now. Where b is the answer here, b is the exponent here, this is going to be helping us solve problems where we don't know the exponent. Okay, so we use logarithms to solve for exponential functions, to solve for the exponent in exponential functions. So I don't want you to use your calculator right now. What I want you to see here is that if we have log base 10 of 100, okay, that's what we're looking for. And another way to write that, and this is going to really help you in class, another way to write that, notice that the 100 is your A here, and this is your B. I'm going, and this is your base. Let's rewrite it into this form. So we're going to convert 10 to the B equals A, which is 100. Well, we know what that better be then. 10 to the second equals 100. We talked about that from above. Or let's look at this one. 10, because this is a log base 10, of what power equals 10,000? Well, we know that that is 5. So this better equal 5. And 10 to what power will give you 1,000,000? And we better know what that is. That is 6. So the logs are giving us what the exponent would be in an exponential function. So 10 to what power will give us 0.01? Well, we know that's -2. We know that this does not exist. Call it DNE. It does not exist. It does not work. And so you'll see here that logs help us solve for exponential functions. Okay, we're going to skip all of this and look at it in class. So let's look on page 3 to summarize the mathematics. I want you to come in and explain to someone that who did not know what logarithms were, to tell us about how y and x are related. And then for B, what can be said about the value of log y in each case? So what can we know if log of, let's say log of 0.5. What do we know about that answer? Or log of 5. What do we know about that answer? Or log of 50. What do we know about that? Or log of 5, we'll use a different number, 300. So I want you to come in class knowing A and B. And hopefully after class, logarithms will be, that you'll understand logarithms very well. So only work that I won't need you guys to come in is to figure out A and B of summarized math. Enjoy your day, and I'll see you in class.